Today we are going to discuss a numerical on limits. So consider this example on show that the limit as xy point approaches origin, the function which is square root of x square y square plus 1 minus 1 divided by x square plus y square equals 0. So we have to prove that the limit for this function of two variables at origin is 0. So we'll use the epsilon delta definition to prove this result, and definition says that for every epsilon positive there exists a number delta positive such that the fxy minus L modulus is less than epsilon whenever the point xy lies in the neighborhood of origin and within a delta distance. So if we can find a delta positive for every epsilon positive such that these two hold simultaneously, then we will say that limit xy approaching origin on the function will be L. Okay. So here function is given, L is the limit point, which is we have to prove that it is 0. So let us start by solving this left hand side of epsilon inequality and see how we can proceed on this numerical. So in this case the modulus of fxy minus L is basically the square root of x square y square plus 1 minus 1 over x square plus y square minus L is 0, so basically we have to solve this modulus. This clearly we can rewrite by writing this function and then multiplying and dividing with square root of x square y square plus 1 plus 1 over square root of x square y square plus 1 plus 1. So in the numerator we have a minus b into a plus b type, so we have a square minus b square, so numerator can be simplified as x square into y square, and in the denominator we have x square plus y square into square root of x square y square plus 1 minus 1, oh sorry, plus 1, this modulus. Now we'll use the following. Say for every point xy in the neighborhood of origin, so that we can clearly see this, that y square will be always less than equal to x square plus y square. for any xy in the neighborhood of origin, this will be true. So immediately we can see that we can utilize that y square divided by x square plus y square is less than equal to 1, and also see that 1 plus square root of x square y square plus 1 is always greater than equal to 2 for any xy in the neighborhood of origin. So from here we can immediately see that 1 by square root of x square y square plus 1 is always less than equal to 1 by 2. So okay, just a second. Okay, so immediately we can use these two results in the last inequality to show that the modulus of f of xy, which is the function this modulus, is less than equal to y square by x square plus y square is less than 1, and 1 over this square root plus 1 is less than equal to half. So the quantity reduced to modulus of x square by 2, and which can be written as less than equal to half of x square plus y square for any xy. This is also true, and suppose x square plus y square is less than delta square, so this can be written as less than equal to half of delta squared, and if we choose this to be epsilon, then immediately we have that for any epsilon positive we have found a delta positive. Okay, so we can say that by choosing delta to be 2 times epsilon square root, we can immediately say that for every epsilon positive we have a delta positive such that the modulus of fxy minus L is less than epsilon whenever root of x square plus y square is less than delta, which immediately proves that as xy approaches origin, the function fxy approaches the point L, or the limit on fxy as xy goes to origin is L. Okay? So choosing this as delta for every epsilon, we have the result.